Sure thing. Yeah, thanks, Katya. I hope you all can see my slide of the Fifth National Climate Assessment. The National Climate Assessment is a quadrennial report prepared and submitted by the U.S. Global Change Research Program, or USGCRP, to Congress and the White House. I am speaking for myself today and not for the USGCRP. The NCA-5 is written by over 500 authors and 260 technical contributors. This slide, showing the table of contents, illustrates the variety and extent of topics covered in the NCA-5. A new feature of the National Climate Assessment this year is the inclusion of art submitted through a competition run by the USGCRP team. You can find these artworks and dozens more at the NCA-5 website under the Art by Climate tab. As chapter lead for the water chapter, I was able to choose my author team, a brilliant group of experts from local, private, academic, and federal organizations from all over the country. With our limited word count, we couldn't cover every water-related climate change topic, so the water chapter focuses on terrestrial freshwater. Our author team discussions guided the scope, findings, and organization of our chapter into these three key messages. I'm going to briefly share our findings for key messages 1 and 2. Key message 1 is about changes to the water cycle, and the evidence we present is about the trends and projections for components of the water cycle like precipitation, snow, evapotranspiration, soil moisture, groundwater, and runoff. We'll start off with observed changes to average conditions. This figure shows how average annual and seasonal temperature and precipitation have changed since the first half of the last century. Temperature is on the left, and you can see that the red areas are where temperature has increased. And precipitation is on the right, and the green areas indicate increases, and the brown areas represent decreases. This figure shows observed changes in snowpack in the western US, where we are heavily dependent on snow for water supply. Snow is a good indicator of climate change because it has direct sensitivity to both temperature and precipitation. The three figures show observed changes in 3 snowpack metrics: snow water content at the top, timing of peak snowpack on the left, and length of snowpack season on the right. And all 3 metrics show a general trend toward reduced snowpack. All of these figures are in the National Climate Assessment with captions to explain all the data and everything. So those 2 slides were about changes in average conditions, and these next 2 are about changes in extreme conditions, and we're still looking at observed changes. This figure shows observed changes in heavy precipitation using 3 different types of metrics: total precipitation on the heaviest days on the left, the 5-year maximum precipitation in the center, and the annual maximum daily precipitation on the right. You can see large regional differences in the rates and direction of change in these figures, with increases in heavy precipitation amounts almost everywhere, but especially large increases in heavy precipitation amounts in the Northeast. Shifting to the other extreme, drought occurrence is also changing. The green areas represent observed trends toward wetter conditions, and the brown areas represent trends toward drier conditions. More drought has been occurring in the southwestern US, with wetter conditions in the center and northeastern parts of the country. So far we've looked at observed changes across the nation. This figure shows climate model projected changes by mid-century in average conditions. So precipitation on the upper left is projected to see increases in, most of the US is projected to see increases in annual precipitation with decreases focused mostly in the Southwest and Hawaii. Snow projections in the upper middle show that despite increasing precipitation, the future climate will have decreases to snow. And in the upper right, we have actual evapotranspiration, or ET. ET is the amount of water that evaporates from soil and surface water or is transpired from plants. And actual ET increases as temperatures rise, but only if there's enough water available to meet the thirstier atmospheric demand. The map shows expected increases in actual ET across most of the country, except in the southwestern and southern Great Plains, where there is expected to be less water available. The next water cycle component that we address in the water chapter is soil moisture on the left, lower left, particularly summer soil moisture, which is critically important for agriculture and ecosystems. The projections show that with the exception of parts of the upper Midwest and Alaska, summer soil moisture is expected to decrease due to warmer temperatures, driving increased atmospheric demand for moisture. And not shown here is a map of projected groundwater levels. Groundwater levels are very dependent on the amount of pumping, but are generally expected to decrease with warming. And the last of the hydrologic component maps on this figure is projected annual runoff, and it's in the lower right. Runoff is the water that makes its way to rivers, lakes, and streams over or under the land surface and integrates the changes we see in precipitation, snow, ET, soil moisture, and groundwater. The models show projected increases in runoff across the country, but the amounts of increase are very small, on the order of tenths of an inch, demonstrating that although annual precipitation is projected to increase by a full inch or more in much of the country, that increase is offset by climate change impacts to the other water cycle components. Those were projections of average conditions, and this figure shows projected increases in extreme rainfall events with the same metrics that we saw for the trends figure in extreme rainfall. There are very few areas that are projected to avoid increases in extreme precipitation events. For future drought conditions, we used a metric called the projected climatic water deficit, which is the shortfall of water necessary to fully supply vegetation requirements. The figure shows that vegetation needs will increase with temperature, but without a compensating increase in precipitation, the deficit is projected to increase. So moving on to key message 2. Key message 2 is about the impacts of the water changes that we just described in key message 1. This figure shows cumulative inland flooding damages across the US and the estimated proportion due to changes in precipitation in green. There have been 230 billion in cumulative damages, of which about a third can be attributed to increasing precipitation. Drought impacts have also been significant. Between 1980 and 2022, drought and related heat waves in the US caused $335 billion in damages. Droughts reduce agricultural productivity and put river and lake transportation at risk, and they are important factors in the loss of ecosystems. So climate change also affects water quality. Changes to ambient temperature, sea level, and precipitation have cascading effects on water quality through hazards like wildfires, increases in water temperature, saltwater intrusion, inundation, flooding, and drought. These water quality issues fall disproportionately on frontline communities. Older adults, children, and residents of low-income neighborhoods and rural areas are at greater risk of exposure to pathogens and pollutants from climate change-driven impacts to water quality. People who live along coasts and rivers or who work in agriculture and fisheries have increased exposure to water-related hazards. Neighborhoods that are home to racial minorities and people with low incomes have been shown to have the highest inland flood exposures in the South. This slide shows the projected average annual loss from floods across the US between now and 2050. The national average annual loss from floods is expected to increase about 26% between now and 2050, but there is a much greater projected increase in losses in Black neighborhoods. Drinking water infrastructure is also aging and deteriorating. compounding issues with water supply and degraded water quality, especially for frontline communities. This figure shows the numbers and locations of homes requiring sanitation facility improvements within the Indian Health Services service areas. The deficiency levels range from minor deficiencies to homes that completely lack a safe water supply and sewage disposal system. So that covers the water chapter, with very brief. I want to use the next two slides to show you some of the other NCA 5 resources available to you. The NCA 5 Atlas here on this slide provides county level projections of multiple extreme precipitation and temperature metrics. It's very useful. And you can find webinars and podcasts on the website under the About tab, and under the Downloads tab, you can find chapter handouts, figures, slides, and translations into Spanish. And that wraps up my presentation. This slide has the link to the chapter and the report website, and my contact information is also on the slide. So please feel free to contact me if you have any questions. And thank you so much.
Thank you, Liz. We'll take a few questions if that's okay with you, Liz.
Yeah. Sure.
Great. Does anybody have any questions for Liz? If you say it loudly, I'll kind of repeat it so she can hear it.
Yeah, so I was wondering if you had, because I'm in the Columbia River watershed, I guess is what you'd say, where you are focused with the Colorado, or do you also take data for the Columbia River?
Oh, yeah, that's a good question. Yeah, we cover the entire country. It's a national climate assessment. So the data that we are presenting is for the entire country. And it's at, I think it's like a 4-kilometer resolution for the projections. Yes, I hope that's
That's a great
helpful.
question. Yeah, covers the entire country. Any other questions for Liz? I highly recommend. We have integrated a lot of the figures from the National Climate Assessment into our curriculum, but it's really high quality. One resource that Liz pointed out was it the appendix that has?
Yeah, it's called the Indicators Appendix, and it has a lot of figures about observed trends.
Yeah, so if you're looking for an easy to find, really well done, authentic data set, figures and graphs, the Indicators Appendix is a treasure trove for resources to use in the classroom. We recorded this, so if you want to go back and find things or listen to things that Liz said, we'll be posting this on the CWE website in the next couple of weeks. So thank you so much, Liz, for joining us. Thank you.
Yeah,
Have a
no
good
problem.
Saturday.
Okay, thank you. Bye-bye.